So on Friday, we converted coordinates from rectangular to polar and vice versa. So today we're going to take that a little farther and convert our equations from one to the other. So to convert a rectangular equation to a polar equation, recall, that means we already know this, that x equals r cosine theta, y equals r sine theta. So we already know that. We're going to use that to help us to convert. Now, keep in mind, just like our x and y, we could have an equation that has an x and a y in it. We could just have an x equals, we could just have a y equals. Same thing with r and theta. It could either have an r and theta, maybe it just has an r, maybe it just has a theta, okay? But if it has an r in it, we make sure that we solve for r or possibly r squared. Okay, so we have here x equals -3. Well, what we know about x, we know that x equals r cosine theta. So where x is, we do r cosine theta. That's equal to -3. Just substituted it in. I need to get r by itself, so I'm going to divide both sides by cosine. So I get r equals -3 divided by cosine theta. Right? And then I can't leave it as a fraction. So what's cosine the reciprocal of? Secant. So this actually becomes r equals -3 secant theta. And that is my answer. Okay, we good with that? All right, so let's look at number 2. So the first thing I think I would like to do in number 2 is to get rid of my fraction so that I don't have to deal with the fraction in this. So I'm going to multiply both sides by 3. So I get 3y equals x times the square root of 3. And then I have something I can substitute for x and for y. So I can get 3, and y is going to be r sine theta equals x is r cosine theta, and then times the square root of 3. So I could divide both sides. I can actually divide the r out. If I divide both sides by r, the r's are going to cancel each other out. So I get 3 sine theta equals cosine theta times the square root of 3. So I no longer have any r's, which is okay, because remember, I can just have an r equals or a theta equals. So at this point, I'm trying to solve for theta then. Have a sine and a cosine on either side. I could divide, and I could either end up with cosine over sine or sine over cosine. Which would you rather have? Sine over cosine, me too. So if I divide both sides by cosine, this is going to give me 3 sine theta over cosine theta equals the square root of 3. So sine over cosine gives me what? Tangent. So I will have 3 tangent theta equals the square root of 3. So then I think I want to divide both sides by 3, and I will get tangent theta equals the square root of 3 over 3. Now I know, like up here, I multiplied and ended up dividing back out, but honestly, having not a fraction to deal with all along was kind of worth it, right? So now I have tangent theta is square root of 3 over 3. That means that tangent has to equal, I'm sorry, not tangent, then theta has to equal what? Pi 6. Very good. So this is a theta equals pi 6 equation, which means it would just be a line. Okay. What questions do we have? Anything? Good? Okie dokie. Then let's look at number 3. I have y equals x squared. Well, I have something I can substitute in for y. So that'll be r sine theta equals x is going to be r cosine theta, and then that's squared. So that'll give me r sine theta equals r squared cosine squared theta. I'm sorry, what? Oh yeah, it's underneath the pink on the left right there. And then, so now, again, I have an r on both sides. I can divide through and cancel an r out. Now, here's a little side note here. because we talked about this not too long ago. If I have 2x squared equals x, and I'm solving for x, am I allowed to divide both sides by x, cancel it out, and lose a 0? No, that's a big fat no. That's kind of what we're doing here. So I want you to understand why it's totally not okay, but here it's a different thing. Here we're solving for x. Here we're simplifying the equation, and we have 2 variables. So since we have 2 variables in there, that makes it okay. If you only had 1 variable and you're solving, you're losing a 0, and that's a bad thing. So I'm going to divide both sides by r. So that's going to leave me with sine theta on the left equals r cosine squared theta. Still trying to get r by itself. So I'm going to divide both sides by cosine squared. So this is going to give me sine theta over cosine squared theta equals r. Okay, so I can't leave it as a fraction like that. I know sine over cosine is tangent, but that cosine is squared, so I'm going to move my r to the left and get r equals, I'm going to make that sine theta over cosine theta times 1 over cosine theta. That way I've kind of split those up. Does that make sense? So now, and I'll write it sideways because I'm kind of out of room, r equals, so sine over cosine is tangent theta, and 1 over cosine is secant theta. Everybody okay with where everything came from? Good? What questions do we have? All right, then you try number 4. Once you're done, double check yourself with me. See if we agree. Ask me a question if we don't, or ask me a question if we do. We okay with all this? Good? Alrighty. So number 5, there's a couple different ways we could work number 5. So we're actually going to do this 2 different ways. So follow with me with the first way. Even if you're thinking, hey, couldn't we have done this? Just hang on to that thought for a minute, okay? Because if you're having that thought, it's a good thing, but I want you to kind of keep it to yourself for a minute. Then we'll see what else we maybe could have done, okay? So I've got x squared plus y squared equals 16. So I know that x is r cosine theta. So if I square it, I get r squared cosine squared theta, right? Plus the y squared is going to be r squared sine squared theta equals 16. Everybody okay with skipping that step where we like put it in parentheses with the square? Just make sure you square them both. All right, so these two terms on the left here, they both have an r squared in them, so what can I do? Factor it out. So I can factor out r squared. That leaves me with cosine squared theta plus sine squared theta equals 16. Then this part should look familiar, right? What does that equal? 1, exactly. So then we equal, that means we get r squared equals 16. Okay, that's my answer. We don't have to get r squared is fine. But one thing yes sir. Well, we've solved for r, even though, like, we've got an r by itself, so as long, if it's r squared, it's fine. As long as r is all by itself, you're good. All right, so one thing we know, like we already put up there, recall that we know this, but we also know from what we did that when we drew that little triangle, we know that x squared plus y squared equals r squared from our little Pythagorean theorem. So since that's true, right here, I could have just substituted that in and said r squared equals 16 and been done with it. Okay? But I wanted to take you through this way because I wanted you to see why that works. I mean, we could have done it this way or that way. You get the exact same answer because of this Pythagorean identity. Plus, you're not always going to be able to just substitute substitute an r squared in there. So like if you look at number 6, can I just put an r squared for my x squared and y squared? No, because they're not being added, right? And if I move it over there, it's going to be subtraction, so it's not going to work. So I'm pretty much going to have to do this kind of thing again. So let's try that. We've got, so x squared, that's my r cosine theta. So this is r squared cosine squared theta equals then y squared r squared sine squared theta plus 1. So just like any time you're solving anything else, I'm trying to get r by itself, so I need all my r's on one side. So I'm going to subtract this over here, and I'll get r squared cosine squared theta minus r squared sine squared theta equals 1. So then just like what happened here, I can factor out a GCF. So I get my r squared times cosine squared theta minus sine squared theta equals 1. Now, cosine squared minus sine squared doesn't equal 1. And although you may have been able to look at this and know what this is without your chart, one of the reasons I said have your reference materials handy, we look on our trig identities reference materials and see if maybe, hopefully, we can find cosine squared theta minus sine squared theta, which is not my Pythagorean identity. But is that on there with something that's familiar? What is it? The double angle. Very good. And which double angle is it? Cosine. Good. So it's that first cosine of a double angle. So we'll get r squared times cosine 2 theta equals 1. Remember, that's not any magic right there. No magic, no memorization. It's from your reference materials, from our double angles that we did. I still don't have r by itself, though. So I'm going to divide both sides by cosine of 2 theta. So I'll get r squared equals 1 over cosine 2 theta. Can't leave it as a reciprocal. Cosine is the reciprocal of what? Secant. So r squared equals secant of 2 theta. And again, it's an r squared, and it's fine. What questions do we have? Anything? Okay. All right, a couple more of these before we convert the other way. Maybe, if my board catches up. Alrighty. So here we've got them squared, but I have a binomial that I have to square first. So a little bit of algebra here. Now I could substitute my r cosine theta stuff in here and then do it, or I could do the algebra first. I think we would probably all prefer to do the algebra with x's and y's instead of cosines and sines if we had, if we're able to choose, which we are here. So we're going to do a little bit of algebra before we substitute. So I've got to actually square that x plus 1, which is not x squared plus 1. Don't make my head explode. Okay, it gives me a trinomial, right? So when I square this, I get x squared plus 2x plus 1 plus y squared equals 1. We all agree with that? So I can see right here, I got an x squared plus y squared. And I know that that's r squared. So I'm going to leave my x squared plus y squared on the left. X squared plus y squared. And I'm going to move everything else over to the right. So when I subtract 1 from both sides, those zero out. So I'll just have a negative 2x there. Okay. Now that I've kind of cleaned that up, the algebra stuff, now I can start substituting. So again, we know that x squared plus y squared is r squared. And that's going to be negative 2 times r cosine theta instead of x. I need to get r by itself. So in this case, I can divide both sides by r. That'll leave me with r equals negative 2 cosine theta. R is by itself. And we're done. Any questions at all? All right, so on number 8, I have to square this one and square this one. So why don't you square them both out, write it out, I'll give you a minute, then I'll write it out, we'll make sure we agree before we move on, so we get all of our algebra correct. Don't make my head explode, because I know you can do this. So we all agree with that. X squared minus 4x plus 4 plus y squared plus 2y plus 1 equals 5. Awesome. Okay, so same kind of deal here. I have an x squared plus y squared, so I'm going to leave that alone on the left. And I'm going to move everything else over to the right. So if this 5, if I subtract 1 and 4 from that, it zeroes out with that 5. So this will be a positive 4x minus 2y. See if you can finish this up. So that's what I got. When you're done, check yourself, see if we agree. Ask me questions if you're lost. Oh, yes, sir. Oh, you could. And so, yeah, so when you're talking about, yeah, right, so the GCF, the greatest common factor, is 2R. So you are correct about that. I didn't care so much about the GCF, just as a CF, but it's fine. Yeah, just the R. But so if you did, like if you ended up right here, you have R equals 2 times 2 cosine theta minus sine theta, that's totally fine. Yeah, that would be the same thing. That's a very good question. Yeah, sometimes we're really worried about the greatest common factor, and sometimes it's really just the common factor, and sometimes you don't know, so you go with the GCF and then see what happens. So that's a very, very good question. So that second one, that would be fine as well. Anything else? But notice that I did factor it out, and I didn't just go like knocking stuff out, because I think that those of you that do that, like you know you're going to factor it out, so you know they're going to cancel out, but then that's when sometimes you think you're canceling things out, but you're really not, and you're like breaking a bunch of rules. So this is really what we have to be doing, is like factoring it out. Okay. Anything else before we move on to the other way? Okay. So now we're going to look at converting from polar to rectangular. So again, it says recall, meaning we already know this because we talked about it on Friday. Well, this we just use those two things. We know those two things are true. And then we actually use that too. And then tangent theta is y over x. But these two, we actually used them on Friday in a different form. Instead of r squared, we really looked at r, and that's equal to the square root of x squared plus y squared. And we really just looked at theta, which was the tangent inverse of y over x. Okay? We had those two things. So just a different form of what's over there. So just writing them down so we can think of them in this form. And then, remember I gave you another little delta math assignment and said it would really be to your benefit to at least look at this and try some of these before class on Monday, which some of you did, some of you didn't. But either way, I'm just going to do a one completing the square. I'm not reteaching it, I'm just going to do it. But because I want you to see it's just algebra. It really has nothing to do with the fact that it's polar. Okay? So if we had, let's say, x squared minus 8x plus 6 equals 0. Okay, so if I have this won't factor. Okay, so if I'm trying to solve it, I can complete the square, or I could use the quadratic formula, but I don't want to solve it. I just need it factored, and it won't factor, so quadratic formula doesn't do anything with me, or do anything for me. So instead, we complete the square. So what that means is this. I'm going to move that 6 over to the right. Okay, so I'm going to get x squared minus 8x equals negative 6. Okay. Then the next thing I'm going to do is I'm going to add something to both sides that will allow me to complete the square. So I will have x squared minus 8x plus something equals negative 6 plus something. And then that something, I take half of this and square it. So this is 16 and this is 16. So that I end up with x minus 4 squared equals 10. And I have it factored. Okay? So that right there, that's just pure algebra. It's going to happen in some of these. We're going to need to do it, but we're not doing it because it's polar. We're doing it because we're trying to get it factored. Okay? Because that could pop up in anything. And it doesn't happen on every single one of them either. All right, so let's go back up here to number 9. So we've got r equals 7. So if you remember when we were graphing these, if r equals 7 and I was going to graph it, that just means I have a circle and the radius is always 7, right? So circle centered at the origin. Okay, so when I convert that, so actually if I knew what my circle equation was, I wouldn't even have to convert. I could just be like, oh, that has to be this answer. But I have a feeling we don't know what a circle equation looks like. So I substitute in for r. These wouldn't make sense because I don't want the cosine theta in there. I know that this is true for r. It's the square root of x squared plus y squared. So the square root of x squared plus y squared equals 7. So I square both sides and get x squared plus y squared equals 49. And that is the equation of a circle centered at the origin with radius 7 in the rectangular coordinate plane. Okay. The equation in the polar is much simpler than that, but they would both graph the exact same thing. Okay, everybody okay with that? Then we look at number 10. Theta equals 2 pi thirds. Well, I know that theta is the tangent inverse of y over x. So tangent inverse of y over x equals 2 pi thirds. I need to get the y and the x by itself, so the opposite of the tangent inverse is the tangent. So if I take the tangent of both sides, I will end up with y over x equals the tangent of 2 pi thirds. So y over x equals, all right, 2 pi thirds is in the second quadrant. Is tangent positive or negative there? Negative. And then the tangent of pi thirds is Square root of 3. Good, negative square root of 3. Want to get y by itself? That means y equals negative x times the square root of 3, or negative square root of 3 times x. That's a little safer to write down. So notice here we tried to solve for y like we normally do when we're trying to get equations. Here I didn't bother solving for y. It kind of depends on the situation, right? I mean, we don't need to force it into solving that for y. That's perfectly fine. Okay. What questions do we have? You solve for y if it's not a squared situation. I kind of feel like you should kind of almost know, like we wouldn't leave it like this because I can easily solve for y. But here, I'm not going to bother trying to solve for y. This is fine. This is actually the equation of a circle. I think it'll kind of be obvious on the ones that you need to leave and the ones you need to do. Okay, we'll see. All right, number 11. So I have r equals 3 secant theta. I'm not going to put the square root of x squared plus y squared right here because I would still have a theta over there. Like that's not going to be helpful here. Because I need to get rid of the r and the theta. I don't have anything to substitute for secant, but I do know that secant is the reciprocal of what? Cosine. So I could rewrite this as r equals 3 over cosine theta. Then, when I want to get the denominator gone, I would multiply both sides by cosine. So this will give me r cosine theta equals 3. I do have something I can substitute for r cosine theta. What's that? X. So this just gives me x equals 3. And I'm done. We good? All right, you do number 12. Easy enough? If you remember on that first day when we graphed the last two graphs we did were the secant and cosecant graphs, and they graphed our vertical and horizontal lines just like x and y do, hence why we have this here. Okay. Any questions at all? All right, so let's look at number 13. I have r equals 2 sine theta. All right, well, again, square root of x squared plus y squared for r, I don't think is going to help me because I still need to get rid of that sine theta. And I can't just put a y here because that's sine theta, not r sine theta. And it's not going to work the same as this because it's not like I can, if I multiply both sides by sine, this becomes sine squared. So if you recall, on some of the ones when we're converting the other way, we had an r squared on one side and r on the other, and we divided the r out, right? So basically the r's been divided out here. I got to put it back. So when you're kind of stuck at, I can't do this, I can't do that, whatever, then I'm going to multiply r by both sides. So this will give me r times r equals r times 2 sine theta. So I'm just multiplying both sides by r. That's going to give me r squared equals 2r sine theta. So I did not square both sides. I multiplied both sides by r. That's what gave me an r squared on the left. Okay, we're all good with that? Now I have stuff I actually can substitute. R squared, I know I can substitute with x squared plus y squared. And that's equal to 2. And then r sine theta is y, so that's equal to 2y. So I need to get all of my variables to the left. So this is going to say x squared plus, and this will give me y squared minus 2y. Now I'm going to have to actually factor that, so I'm going to have to complete the square, which means I'm going to have to add something here. When I subtract the 2y away, that becomes 0, but I have to add something else. Because I'm going to have to factor this y part. I don't have to worry about x because I didn't have like a lonely x, but I have this lonely y. So I have to complete the square here. When I do that, that means I'm going to take half of this and square it. There's a 1 here. If I add 1 to this side, I have to add 1 to that side. So then this is going to give me x squared plus y minus 1 squared equals 1. And that's the equation of a circle centered at the point 0, 1 with a radius of 1. It's our circle that's not on the origin and the polar coordinate system. What questions do we have? All right, you do number 14. What am I going to have to do first on 14? Multiply both sides by r. What number am I going to have to add to both sides? 9. Add 9 to both sides. Huh? Why is it 9? I take half of this and square it. So this is x plus 3 squared plus y squared equals 9. It's possible, excuse me, like we have this lonely x. It's possible to have a lonely x and a lonely y. So you might have to complete the square on both. But I only had to do it on x on this one. I only had to do it on y on this one. But if I did have to, if this was y squared plus 4y or something, then I'd add something else over here. I'd also have to add it over here. Okay? What questions do we have? We good? Awesome. So your assignment is on Cami. I do have one little thing I need to say, is that on the second page of the assignment, I try to give you tons of room. One of my little stupid fraction bars disappeared again. I don't know where they go. They're all off having a party laughing at me somewhere. But I think you probably could have figured that out, but I just at least wanted to say it so you weren't confused.